shared recently. But I'm also interested about you guys. This is a full room, and you also have interest in file mapping language. So can you get a hands up if you are a business analyst who is interested in file? Yep. And if you are a programmer who is interested in file? Oh. That's tough. Okay. I know what all are. No. Alright.
You might speak a little louder or use a mic.
I don't see there's a microphone, so I'll speak louder.
No, we don't have a microphone for this room, so.
Okay. Right. Let me know if you can't hear me in the back. So, the structure of this presentation will be in two parts. We'll go over the language overview, and we'll go over the basic syntax of the language. And then I'll also show you how to do some common things with file mapping language, so you get an idea of how it works. First of all, why new FHIR label thing? Graham said in his earlier presentation, for portability. There's nothing available right now that you can share across various implementations. No existing standard for the build. DMI is there, but it didn't do the job quite well as it needed to. And of course, proprietary solutions were out of question. Enter with that file mapping language. It is a declarative language, no procedural language, which means that you state what you want to happen, and the engine decides how it is best to accomplish that. It takes off the best parts of QET, which is a query transformation language. Ray mentioned it. It leverages the design philosophies as FHIR. It allows you to convert between FHIR resources, including different versions, including other formats, CDA to D2. And you can also add support for your own custom stuff as well. If you implement the interface that it needs to traverse object trees, etc. The status of it is very young. The maturity level is 0 right now. It's very, very new. Just about a year old. Be suspicious of anybody, but claiming to be an expert. That includes me. No one claims to be on it yet. How does it work? What's the bullet points? No, file mapping language, the rules are divided into groups, and there's rules within these groups. By default, in file mapping language, nothing gets transformed, which means that you have to be explicit about every element. If you don't state something about an element, it will not come out the other end. Which means that for Graham's work of creating maps, which was transformed from TS2 to TS2-3, he went through every data type, he went through every element in the resources. He did a lot of work. This is a sample of these groups. You see we have a group that has name sample group. Within the group, you specify your source and the target. So you will be working with allergen tolerance. One's DSTU2, one's DSTU3. And these are the rules. You can see there's a bit of variation. First of all, this is the rule name. You can either have it be asses, or you can have it in quotes in case you want to have spaces in them. And then for the rule, you say for source.text. Source is an element from here. This is the source element. We take the text field and we make in the target output and output text. So we essentially copy the value across and keep the same element name. This is another rule. This is a variation. Now this is the simplified version. This is a bit more complicated. For source.id, we store our ID as a variable called var. And then in the target.id, we assign that variable. Storing it as a variable allows us to do some transformations on that variable, which you'll hear later on. And of course, if you have a rule that you want to rename elements, it's happening file, element get renamed, you can do for source.identifier, make target dot, and then you give it a different name. So copy the value across, but it'll go into a different element. If you have any questions in your presentation, feel free to ask. So there's 6 important bits of a FHIR map. First of all, you have the metadata that describe what are your inputs, what are your outputs. You can optionally have embedded concept maps in it if you would like to translate codes from one code system to another code system. you have references to the structures involved in mapping. So these are your structure definitions. They are your input and output schemas. So the language knows how to order your things. And what are the types of your elements as well. Imports, you can import additional maps. So this allows you to do map reusability. You can have a map with basic data types. You always import into your map to do the low-level conversion. And then you have a series of groups. Each group has your input variables, and within each group you have groups. So those are the 6 essential bits of a FHIR map. Let's start with the first one, metadata. Metadata is mandatory. The syntax is like this: map, you give it a canonical URL, and you give it a human name. So for example, we can go map, structure map / tutorial, and we get a human name of tutorial. This will be the very first thing in the file mapping language. Next is the concept maps. These are optional. These are if you want to translate codes in your map. So the syntax is concept map. You give it a name, prefix s, this is the source, and you give it the source canonical URL, and you of a code system, and you have a prefix target, and you give it the target canonical URL, and then for every code, for every output code, you specify which is the input code. An example here. So here is our example of a FHIR map so far. Here's the map that we declared at the top. And here is our allergy intolerance criticality concept map. And it will translate the CRIL code to a low value. It will translate the CRIT code to a high value, and CRIT-U to unable to access.
I'm not sure I understand this. So the top part I understand. The bottom part you want to explicitly, like if you take SNOMED, there's like 600,000 codes there. If I take ICD-10, there's like 110,000 codes. Am I supposed to list them all here, how they map to each other? Like I just want to import a concept map.
No, I think you might.
I don't want to write the concept map here. I want to import.
Yeah, this is for a small concept map if you want to be explicit about it.
Okay.
I think you can call out to a terminology server to also do the translation for you.
Okay, okay.
Next, these are the structure definitions used in our map. They give the mapping language the schemas that you're working with, so it knows the types, and it knows things like cardinality, etc. And the syntax for that is uses, and then you give it the canonical URL. And you can also give it an alias, and you specify the mode. So the mode can be either the source or the target. So here, we'll say uses the STU3 structure definition, allergy intolerance, and our target will be the DSTU. It will be downgrade from STU3 to DSTU2.
Question.
Yep.
Is there only one source? What if there's essentially a conversion would involve like joins or something like that?
We can have multiple sources, and we can also have multiple targets as well. It's pretty flexible. So here's our example so far. Map, so concept map, and we declare our source and targets. Next, we can have additional imports. If we have our base maps that we would like to make use of, we can specify imports, URL, and it supports an asterisk for globing. For example, if you want to import a whole bunch of structure maps that end with 2, 3, you can just drop it in, we'll import them, and the rules specified in those maps will be available for use. Next, we get to the groups. And groups are really the meat of a FHIR map. They specify, they contain rules. Each group declares its inputs, and it declares what are those inputs. Is this the input as the source, or is this an input to the group that is meant to be the target output? So in an example, we can just say allergy intolerance is the input and the output, and it'll take it from STU3 and transform it down to STU2.
Is the source following the input arbitrary, or does name have to be source or target as well? See, I see source appearing twice. Input source as source.
This is a name I gave it.
Okay.
This is the mode, so this has to be as source and as target. This is the name. I could have called it input CRC,
Okay.
input A, input B. This is just the name. So here's how our example looks like so far. Map, class of map, our uses, and our group without any rules so far. Let's get to the real interesting bit. Actual rules. I've shown the syntax to you a little bit before. The basic syntax is the name of rule, colon, and then for the source field, as whatever value you make the target field as this value that we save that. For example, for a rule called rule underscore text, or source.text as var, target.text as var. Simple rule across. So here is how our example looks like so far. You will see that I've added two rules, and I've added a rule to translate the code as well. So if we have an input element called criticality, we would like to transform the contents of that element to something else. So we can do for source of criticality, make target good of criticality, and then we call the translate operation. This translate operation will take the variable criticality as v, so it is v, uses the allergy intolerance criticality concept map, which we define here, and it translates the codes. So it comes across any of these guys, it'll output this back. Yeah.
Two questions. Where does the code come from?
The code is a type. Criticality is a type of code. This is data type.
Okay. So, okay. Okay. Why do I need to name rules?
You mean this?
Yeah. Like the rules are just, all the rules are applied, I see.
All the rules are applied, yes. We give them names so you can debug it. You can see which rules ran.
Okay. Is that optional?
It's mandatory. It's mandatory, but you are, if you don't want to generate unique names right now, you don't have to. You can always
The names are the names only go in the log. That's the only.
Yeah.
But, and they're
Should be
also for
optional.
people to talk about them. And the reason they're mandatory is because what we do is we make everything mandatory till people argue about it.
I would argue that it should be optional.
The real reason is traceability, of course. Ben mentioned the traceability is super important, and you want to have traceability of what ran and why you did something else. So you want to give them good names for traceability purposes.
Yeah, so I can imagine a scenario where the rules are generated by another program, in which case the name will be generated to basically be the encoding of the rule, to which point it doesn't really help to name it. But
Still-
we can argue about it.
still where in the log.
Okay.
Yeah. So, that's it for the basics. There's those 6 spots. If you have any questions, feel free to ask. Give me super questions. I'll have to answer them. Yes, Alexander?
You showed what it looks like when you not fire the fire. What if one of the two is not fire? What do you specify for the URL? Or do you not have to specify the URL? So if it's a physical message, CDA, what have you?
You would need to feed it a structured definition. In a structured definition, we need a URL.
So your starting point for anything non-fire is create a logical model first.
Yeah, needs to know this word.
So there's actually 2 answers to this. One is it needs an implicit logical model which just says names, types, cardinalities, and actually it doesn't need to be explicit. And there's some things logical models can't describe that you could describe with names, types, and cardinalities. But if you don't have a structure definition for it, then you need to do some code. And so if the question is, can I do it in the default libraries without doing any code, without a structure definition, the answer is no. But if you don't have a structure definition, you have to write some code that plugs the stuff into the library. It's the same interface that we use for FHIR, right? At the library level.
Just a quick comment on your examples. Rule text as input sources source. It was difficult to understand whether that was part of the language or a label. If you could my in or something into the examples so that because I thought, oh, there's something that says I have to declare rule text, not realizing.
No, that's just an arbitrary name that I gave to my rule. Any questions? No questions at this stage? Yeah.
When you copy values across the way, can they apply them or just compare them after? Like they're complex things.
There's two answers.
I'll do it.
Either they have to be primitive types, which are the underlying primitive types, string or whatever, or if they're complex, then there's a way to define default rules for converting complexes from source to target. And so then the engine will have to go off and find a rule that's applicable for what you've just specified without explaining how. And then if it can't find a rule that explains how, then it goes, well, can't do it. Otherwise it'll find the default rule. So I think you might get to that under advanced.
Yeah. I'll show you.
I have a question.
Yeah.
Suppose it was FHIR structure definition ADT A01, and that's a message in V2. How will you say in that language that you want the first identifier in repetition go to the first identifier and the second to the second in the patient resource?
You can use the FHIR path to extract data.
Well, I want to create two.
I think I got you.
I want to create in the patient resource. I want two identifiers because there were three identifiers in the source. How you write that in your rule?
You'll be able to write more rules to cover it.
How do you express mapping one list to another? Maybe reordering or getting only a portion of it. I think that's what it is about.
The order would be controlled by the structure definition that you feed it.
Have you?
I don't want to change it. I want just the first in the first and the second in the second.
So it's like appending. Like say, if I find this element, then I add it to this list, and if I find this element, I also add it to that list.
Yes.
Possible?
I'm not sure.
So have you done actual list mapping yet? It's one area that's pretty difficult to manage. But you can just say the different things map to the same element and it'll just automatically get a list. In terms of controlling order, that's kind of tricky. You can say I want this thing to go first or last, but you can't. And then what happens if two things want to come first? That's a clash. But we haven't given really good control in the language yet over the order in the output.
For identifiers, the order would not matter.
From there.
So in this case,
Depends on the direction.
Well,
maybe.
in for example, in the XML output, the order does matter.
Right.
I thought in a FHIR, maybe I misunderstood the spec, but I thought repeated elements you should not depend on any order. If you care for the order, you should have an attribute that is called rank or order. But like the order in which things are serialized is not. I didn't know it was. You should depend on it.
That's true if you map to FHIR, but what is if you map from FHIR to something else, which is order specific?
It's not strictly true. I mean that's a whole question to itself whether order matters in a list. So for instance, say you're dealing with a composition and you go, oh well, you know, I can just reorder the list and just reorder the document. People might get a little bit unhappy about that. So as much as possible, we do encourage people not to get too attached to the physical order of items in the list. But you know, sometimes that's how things work, and you've got to deal with that. We haven't actually run into any use cases around needing to reorder lists, and if you look at most the specs that I've dealt with, the thing we really care about which comes first, and we don't really often care about order after that, other than there's a sort of implicit order. So it's an interesting question, but as much as possible we encourage people not to get too attached to order.
Question. Can you use variables, source variables across rules?
You can pass them down to the other groups, to other rules.
It's not just within the rule. So far, it's not feasible if it's rule criticality. Yeah, that's what I read.
Yeah.
It is or is not?
I don't think it is. It's not. It's the scope to this.
Oh.
Alright.
Yeah, Alexander.
Yeah.
Yep.
Suppose I have this great allergy intolerance mapping and everything works out.
Yep.
And now I have a bundle that, among other things, contains allergy intolerance. Can I reuse this mapping to not have to re-specify the thing for a bundle? Can I import this mapping somehow and make it useful?
Yeah, that is my understanding. Yeah.
I read something about it, but it wasn't quite clear.
Yeah,
how
that's
to
what
use it.
the input statement allows you. It allows you to pull in those groups, and when you're processing your bundles, it will be groups that are matching the input and outputs. That group will trigger and around those groups.
So my next question would probably be along the lines of, suppose not every allergy intolerance is the same allergy intolerance, and some needs to be different than others. Can I?
You can also explicitly call. You can also explicitly call groups for processing.
Right.
So you can have a choice there.
Then we're good. Thank you.
Yeah.
Can you talk about joins?
In what way?
So, okay, I get the background of my question is if the use case is to like map one thing at a time, then the expressivity of your mapping language here is fine, like you can execute it. If you're thinking about mapping over like a few million, 100 millions, billions of records, then the expressivity kind of matters. And so when you can do joins from different sources, so if you need to map, you know, 2 different sources to a target, and if you think about doing this over a billion of records, you want to parallelize it. And so now I need to kind of know, how do I handle joins? So I guess my question is, what kind of joins are supported in this language, or should be supported in this language? But I'm not sure if that's a basic question. I know, we can take it also offline.
Yeah. The answer is that there's an implicit assumption in the language that you start at a focal point.
Okay.
A single focal point. You can reach out and reach into other content and say, this other content I need to find or I have or dereference to bring into what I'm doing. And that's a form of a join. But I'm not sure it's the form of join you want at scale. On the other hand, one of the ideas here is because it's all declarative, you can parallelize lots of stuff.
Yep.
So, but we didn't sit down with the use case of transforming 100 million records. Maybe we should have, but we didn't. So we can talk about that.
Yep. Yep.
I think that comes back to the identity of the things you create. And based on the work I did with Keith, if it's following that semantics, then you should be able to do that sort of parallel traversal over the rules.
Yes, Keith cared greatly about that, and we believe that it's maintained.
Yeah.
Cool. We have one expert here, so now's the time.
I apparently know beforehand what my sources and targets are, but I might encounter more as I traverse the tree. Can I dynamically call out to other sources as I see fit based on the data?
Yeah.
I would create a use statement somewhere along the way. Is that how it works?
You need, the user statements are at type level. You need to use everything you might encounter so that you've brought everything in scope. Although then you can call out to other libraries and you have the default stuff to fall back on. And if you look through all the version transforms between release 2 and release 3, you'll find every one of these techniques used somewhere in there. For instance, you're asking about, you know, in a bundle, well, you just have to look at the bundle transform and you'll see it. And there's a few places like value set to value set and code system bidirectional transform is worth having a look at, because that was kind of fun to get hold of that one. That does all of the joining stuff. So they're all there in there somewhere.
That's what I actually did in preparation for this presentation. I trawled through all the maps that you've written and pulled out handy examples. So now actually, as I mentioned, we can go over some of these examples and see how to do these common things in language. So first one we've seen. The next one is, if you like to create a default element, if nothing in the input is present, you can use the FHIR path to state a where clause. So for example, over rule there's no code, you do the form source. So when picking a particular element, we just take form source. I run this FHIR path expression where code.exist or not. So there's no code. And then we can create a thing in the target called substance, and CC is allowed to create a code, type code, and then just drop in the code system there, the code, and display name. And the where clause, this little bit is run using FHIR path. So this allows you to create filters on your rules, so just elements themselves. Map codes, we've already seen this example. This is a translate operation. Map codes will be embedded in the concept map here. You can filter your rules based on the values at runtime. So for example, if we have the source or status, where the status is not repeated and it is not entered in there, then we can map this field and we can create a clinical status using our translate operation. So you can use this to check for the value. Yeah.
Because it's named as V as well, so in the FHIR path you refer to it as this.
Yeah.
But wouldn't it be handier to like call it V, or is that clashing?
It's a long story. It would be handy, but there's name resolution problems.
Because you have a different environment for
Sorry?
probably have a different evaluation environment for the FHIR path. Is that you would have to insert the name, of course. Okay, well maybe it's
yeah, for later then.
Let's do some hard question. I showed you where before. You can also use a word called check if you would like to error out. So where, if a rule doesn't match, it'll skip it, but check allows you to actually error out your transformation. So here, we can make sure that we only have, for example, one category in the input. So we can do source or category as a check with the source or category that count. This thing is a FHIR path expression, is less or equal to than 1. There are multiple categories, so transformation will fail out and stuff. You can also organize your maps with inheritance. So you can say one group extends another group, and the FHIR R2 to R3 maps always use this. They extend domain resource and they extend element to pull in rules that way.
Can you extend more than one base?
No. In my count,
It's not a polyarchy.
in my count, for the source and destination materials that I've heard of, there's one specification that does true polymorphic, true poly inheritance in the structures. And I decided that wasn't enough to introduce all that complexity.
What is the difference between importing a map and inheriting a map? Because
Extending?
yeah, I mean, I assume the semantics of multiple rules is just they will be applied in arbitrary order until we're done.
Yep.
So what's the difference between importing and inheriting?
If you import, you're just bringing the namespace in the scope.
Oh, they're not necessarily run.
Yeah. Yeah,
Oh, I
yeah.
see. Okay. Okay.
This is what Alexander, you were asking about. If we would like to run our groups, we can just do this. For example, for source of the action is X, we target the action is Y, and we have a reaction group. We pass these two variables, X and Y, as our two inputs to that group. That's one way. Other way is to also just declare your other inline with the pointy brackets. So you can do, for example, for source.event SEV, and save as variables SEV, and then here you can have for EV.type, so you go into the EV variable, target.type, EV.action, target.action. And also transform the contents of your elements FHIR path. For example, if we want to chop our string up, and make sure it's no longer than characters, and FHIR path expression for source value as B, and targeted value, and then run FHIR path, and this will do FHIR path and take out the substring of that value. We can also be more specific in our matching rules. We don't have to always match by name. If there's, you can also use the elements type to match, for example, in our source.alpha, we don't make sure if it's string or reference. We can ensure that we run the reference rule. So when offer is of type reference, we'll run this rule, and when offer is of type string, we'll run this rule. So you can match not just on the element, you can also match on the type, and further, you can also even match on the cardinality that the element is using in the schema. And I think we're unfortunately at time now.
Yes.
For attending, an expert in the room. I hope this was, a good briefer to the FHIR mapping.